Hello guys, welcome back to Oxford's Metalworks and welcome back to another video. This is a piece of 304 stainless steel. Well, this is a LED light housing which are mostly used in swimming pools. Okay, they are mostly below the water line or below the water level, and there are two mounting holes for holding this in place, and this is the LED light which goes inside of this, and these are the measurements for a acrylic template, which is the acrylic sheet which is resined here. This is just a cardboard piece, but you get the picture. When the LED housing goes in to create a waterproof ceiling, and this entire assembly goes below the swimming pool. Now we have received certain pieces. As of now we have received 4 pieces, and there are another 10-15 more to come. We have already started with the project. As you can see, we have done this inside counter board for the LED housing, and the acrylic sheet fits nicely. This is how the final assembly would go in. As you can see, this goes in and this covers up. This would involve us a lot of lathe work. So we are going to use these 2 lathes to do the lathe work. There is a hole, 9.5 millimeter hole. This is a counter bore. This is the 19 millimeter depth with an OD of 91 millimeters, and then we have a recess where this acrylic sheet is going to sit, which is 93 millimeters, and then there is a OD work, chamfer work, and then some milling work to drill some holes. So the first thing that we are gonna do is we are going to put a center drill in. The reason we are putting a center drill, because we are going to machine this in the other lathe, because that other lathe is faster. Meanwhile, we are going to use this lathe for the secondary operations like turning the OD and facing the back end in this lathe, because it is very easy to mount it like so and use the inside jaws. You would see what I mean when we do that. It is easier to show than to tell. So let's first do the center drilling on the part. So we are going to use some oil. Okay, so one done. So this is the second part. Okay, this is done too. So this is the piece, the blank, which we have center drilled. Now the reason we have center drilled is because we have a dead center, and if we put it here, we can indicate the dead center to get this part roughly aligned. Now, as you can see, there is a runout in the dead center. Why? Because this part is not running through, and we can confirm this with the help of this dial indicator. You can see the amount of runout we have. It's a lot. So we are going to true it now.
A few moments later.
Alright, the part is mostly true. So the total runout that we are achieving is 0.03 millimeter. That is the overall, and the part runout is half of that. So we are okay with this. No need to be more precise than this one. So we are ensuring that all jaws are tight. The runout is the same. So this is a 7 millimeter drill, so that we can drill the pilot hole. Increase the speed a little. Alright. This is a 9.5 millimeter drill. Now this is going to be the final drill size to accommodate the wire of the LED light. Okay, this is done. Okay, as per the drilling is done, but then because we need to create a bore over here, and we have this and we have this boring bar which is a lot wider than the hole we have drilled. So we need a pocket where this end mill can go and cut it. We are going to enlarge this hole a little bit by 1 inch. So for 1 inch, this is a 16 millimeter drill that we are going to open it a little, and post that we can go to the 1 inch drill. So we are going to use some cutting oil. Reduce the speed. So now we are going to finish off with this 1 inch big drill that we have. This is just to enlarge the pocket so that we can have some space for the boarding bar to go. This end mill requires a little bit of dressing. This drill requires a little bit of dressing because it is not cutting equally on all sides, on two sides. but as of now this will do. Alright, because we are machining this in 304 stainless, it is a lot harder material than any EN grade steel, so we are doing this a lot slower. This process is taking a lot more time because the material is very demanding. Alright, it is faced off. Now let's give some depth and start cutting. Now we are making this recess. This is face like this, and now we are machining this recess. So this is going to take some considerable amount of time. So let's check the hole size. So this is alright with us. So the pocket which we are creating is 86 millimeter in width, and we need to go 92 millimeters. So we are going to go to depth of 19 millimeters, which is the pocket depth, and then we are going to bore this another 6 millimeters or so.